Good afternoon. Now we are discussing numericals on venturimeter under fluid dynamics in module number 3 of the subject fluid mechanics. So a pipe that is 200 meter long slopes down at 1 in 100. So that is so the slope is now 1 in 100. So that is, so if you move 100 units horizontally, so there is, so the slope of 1 in 100. So 100 units horizontal, 1 unit vertical. So that is the slope. So it tapers from 600 millimeter dia at higher end. So that is at higher end the diameter is 600 millimeter and at lower end it is 300 millimeter. So here it carries 100 liters per second of the oil. So that is okay, the discharge is given as 100 liters per second. So and the oil specific gravity is 0.8. So if the pressure gauge at the higher end, so that is the reading of the pressure gauge is having the reading of 60 kilonewton per meter square. Neglecting the losses, you are asked to determine what is the velocity at both the ends and what is the pressure at the lower end. So given data is written here, that is diameter of the pipe at higher end D1, so that is 600 millimeter, and the area is now pi D1 square by 4. So then diameter of the pipe at lower end, that is D2, that is 0.3 meter. So area is calculated. So then we have height of the lower end. So it is exactly at the datum. So Z2 is 0. Now the rate of the liquid flow, so that is given as 100 liters per second. So that is 0.1 meter cube, because we know that 1000 liters is 1 meter cube. So 100 liters means 0.1 meter cube per second. So pressure at the higher end here, P1 is known, 60 kilonewton per meter square. You are asked to find out what is P2 and what is the velocity at both the ends, that is V1 and V2 to be calculated. Velocities V1 and V2 to be calculated. Now Q is equal to A1 V1, that is equal to A2 V2. So where V1 and V2 are the velocities at the higher and lower side respectively. So V1, using this, it is Q by A1 and V2 is Q by A2. So discharge Q is 0.1 meter cube per second. So that is substituted. A1 and A2 are substituted to calculate V1 and V2. So since the diameter of the pipe is changed, as we see the case of venturimeter where there is gradual decrease in the diameter of the pipe. So here also considering diameter change in the flow from diameter D1 to D2, it is gradually reduced with the slope of 1 in 100. So we have different velocities here. V1 as 0.35 meter per second, V2 as 1.41 meter per second. Now it is asked to calculate pressure at the lower end P2. P1 is given. So taking the help of Bernoulli's equation of motion at both the ends of the pipe, we have pressure head plus kinetic head plus datum head. The sum of the three heads are taken on both the sides. So P1 is known, substituting that W is nothing but rho into G, P1 by rho into G. So density of the liquid is given here. So that is specific gravity is 0.8. So it is 0.8 into 9.81 rho into G. P1 by rho into G plus V1 square V1 calculated, substitute here 2 into G 9.81 and Z1. So the pipe, so here I have, so 200 meter long. So if you have 1 in 100, so that is for 100 meters horizontal coverage, so 1 meter height. So for 200 meters length means it is 2 meters. So that is the point on the axis of the pipe is exactly at 2 meter height from the datum line. So slope of 1 in 100. So for 100 meters 1 meter height, for 200 meters 2 meters. So Z2 is 2 meter, Z1 is 2 meters, Z2 is 0 because the lower end is exactly at the ground level, that is on the datum line. So that is here Z2 is 0 but Z1 is 2 meter. So only P2 is unknown. So substituting everything, so it is asked to find out P2. So P2 on simplification we are getting 74.8 kilonewton per meter square. Now another problem, the pipeline is carrying the oil with the specific gravity 0.8. So change in the diameter is 300 mm at section 1 to 600 millimeter dia at section 2. So diameter D1 is 300 mm at position 1. So area of the pipe is pi D1 square by 4 and the pressures at both the positions 1 and 2 are given. So pressure at 1 is 100 kilonewton per meter square, that is taken. So discharge of the oil is given, so that is 300 liters per second. So in terms of meter cube it is 0.3 meter cube per second. Specific gravity of the oil is given, so that is 0.8. So weight of the oil is now rho into G, so that is rho is now with the specific gravity of 0.8 into 9.81. So rho into G, so many kilonewton per meter cube. So at position 2 the diameter is given, pressure is given and datum, so that is 5 meter at a higher level. Position 2 is at 5 meter above the datum line. So here datum for Z2 is 5 meter. So here position 1 is taken on the datum line. So Z1 is 0. So loss of the head HL will be calculated here. So total energy at position 1. So sum of the 3 pressure heads are taken. Substituting everything we are getting E1. Then total energy at section 2. The sum of the 3 heads. Pressure head plus kinetic head plus datum head. Substituting everything we are getting E2. So that is 12.76. So the difference of E2 and E1 is nothing but the loss of head. So that is 0.9 meter. So E1 is 13.66. E2 is 12.76. So E1 is greater than E2. Therefore flow is taken place from position 1 to position 2. Where the energy is more, it flows to the place where the energy is less. Thank you, friends.